In this video, I'm going to continue to go through questions from the Math 2015 PAT. If you haven't seen the previous videos, make sure you check them out here. If you have, let's continue on to numerical response number 8. Okay, number 30 here. So with this one, this is again another one that I would say would make a good one to use without a calculator. So what we want to do is we need to evaluate the expression and decide which one has the lowest value and which one has the highest value. So let's go ahead and evaluate this. So we're going to use our exponent laws. So 3 to the power of 2 really is saying we've got 2 to the power of 6 plus 2 to the power of 2. Well, that's going to be 4. 2 to the power of 6 is 2 times 2 times 2 times 2 times 2 times 2. So that's going to be 64 plus 4. That altogether is going to give me 68. Okay, let's look at the next one. This one we know just goes to 1. Anything to the power of 0 is 1. So now we just have to evaluate 4 squared. Well, 4 squared is 4 times 4, that's 16. 4 times 4 times 4 is going to be 64. And then we got to take away that 1. So that's going to give me a total of 79. And in our last one, we're saying 4 times 4 times 4 times 4. That's going to be 81, sorry, take away 3 times 3, which is 9. That leaves me with 72. Now our question asked us to figure out the lowest value and the highest value. Well, my lowest value is going to be expression 3 at 72. And our lowest value is going to be 68, expression 1. That means our answer is going to be expression 1 and expression 2, so answer B. Okay, number 31 here. So we have an inequality that we're going to be solving here. So for this inequality, we've got inequalities on both sides. So whenever we do have inequalities on both sides, we want to do our best to make sure we move the smaller one. We also have to remember if we are dividing by a negative, we need to flip that sign, okay? All right, so let's get started here. So what I'm going to do is just like last time, I'm going to go ahead and rainbow in that number outside. That's going to leave me with 8x minus 4 is greater than 4x plus 8. Now let's move our smaller x. So my smaller x is going to be the 4x. So I'm going to add a negative 4x to both sides to cancel that out. Rewrite everything. And then now, as always, we want x's on one side and numbers on the other. So I'm going to add a positive 4 to both sides. That's going to leave me with 4x is greater than 12. And then we want to get x alone. So we're going to divide both sides by 4. So x is less, oh, I don't need to flip the side. X is greater than 3. Now with this question, if you haven't seen it, I do have a little trick here. What we can do is as long as our variable is on the left side, we can use that to determine the arrow in the direction that it's going to go on our number line. So that means our number line has to be pointing into the right, which means I can cancel off these two. And then we just have to decide if it's going to be a solid circle or just a circle. So because there's no line underneath it, it's going to be a solid circle. Or sorry, because there's no line underneath it, it's not going to be a solid circle. So it's going to be option A. All right, numerical response number 7. So a store owner pays a sales clerk $12 an hour for each hour worked. The assistant manager of the store earns an hour and a half time the clerk's hourly wage. Okay, that's going to be important. In fact, I'm going to highlight that. 1.5 hour times the hourly wage. The manager of the store earns 2.5 times the clerk's hourly wage. Getting tired after filming all of this. Okay, so what we want to do is we need to figure out how much money is paid to the 3 employees in one day if they worked a 7.25 hour day, okay? So we have to think, we've got 3 different kind of players. We've got the sales clerk, the assistant manager, and then the manager itself. So 3 people that we're worried about. So for our sales, we know the salesperson is going to be earning $12 per hour. Okay, so now the assistant manager Well, they earn 12 hours, $12 per hour, but times that 1.5 that I highlighted above. So that's going to leave us with 18. Now the manager itself, again, we're going to use 12 as the base. They earn 2.5 as much. So I'll have to multiply that by 2.5. That's going to get me to $30 per hour. Now, what we want to do is we want to add that together to figure out how much money they each earn per 1 hour. So that's going to be 12 plus 18 plus 30. That's going to equal our 60. Now that's per 1 hour. We're going to go 60 times 7.25. That's going to leave us with a total of $400. I'm assuming this is before taxes. $400 and $435 per that 7 hour and 25 days. $435. Okay, number 32 here. So if the 2D shape shown below on the Cartesian plane is reflected about the y-axis, we want to know, is reflected on the y-axis, If the original 2D shape and the reflected image combine to form a new 2D shape, what is the angle of rotation of the new 2D shape? Okay, so this is an interesting one. So the first thing we're going to want to do with this is we are going to want to complete our shape. So just like last time, I'm going to use those points to help me out. And this time they kind of gave us the points because they do want you to draw it. And remember, with your PAT, you can always draw them. You can always write on the PAT is what I'm trying to say, sorry. Okay, so here is our new shape. So now what we're saying is the two originals are reflected and that becomes a new shape. We want to know what's the angle of rotational symmetry of the 2D shape. So what this means is we need to, of course, know what is angle of rotation. So angle of rotation is basically how many times we have to turn it in order for it to fit itself. So we can, in a traditional sense, we would normally use tracing paper, but what I'm going to do is use this here. So here is my shape, and basically I can't copy the original one that was on the PAT, but I've got the one that I drew. So what we're going to do is we're going to rotate it. So I'm going to rotate it 90 degrees. Well, if I rotate it 90 degrees, it's not quite the original shape, right? It's not the original one that we got. But if I rotate it 180, now I have my original shape. So this means my rotational symmetry is going to be 180 degrees. So that means its order is going to be 2 with 180. And I could also figure this out by saying that if it's 360 degrees for my whole structure to rotate, and if I take 2 rotations, that's also going to give me 180 degrees. So our answer for this one is going to be B. Okay, let's look at this question right here. So what we need to do is we need to match the following surveys into the data collection problems that each question might have. So looking at this, we're looking at a bias. So a bias is when you have a preconceived notion or an idea of something already, and it might sway how you answer something. The next one is use of language. The third is privacy, so making sure the information is collected in a certain way or not revealing certain information about people. And finally, the time and the timing of the question. So why don't we go through these options here, read them first, and then we can match it up to the different collection problems. So our first one says, customers in electronic stores are asked whether they would purchase last year's model of a television or wait for this year's new and improved model. A random sample of grade 9 boys is asked to determine which snacks should be available in the school's vending machine. During the summer, every household in a large community is asked to complete a detailed questionnaire to determine whether the local skating rink should be renovated. Finally, grade 6 students are asked how many times they wash their hair each week. All right, so looking at something like this, I already noticed a couple of things. So with this one here, we're asking in summertime, probably when people's minds aren't on a skating rink, we're asking them to answer a question here. So that one definitely is gonna go towards timing. Now I'm also looking at this, and for number 4, they're asking how many times grade 6 students wash their hair. That one's going to be more towards, I would say more towards privacy, right? There's definitely some issues there with privacy, so I'm gonna go ahead and pop those in there. And then now we just have the first 2. So with this one, we're looking at whether or not they would purchase last year's model or wait for like this year's model. So the thing with that one is we do have a use of language here, right? So we're asking someone, hey, do you want what's old from last year or do you want something new from this year? So that one's definitely going to be a language problem. And then finally with number 2, our statement here, we're asking random grade 9 boys. So the fact that it's random is great, but the fact, of course, you're asking teenagers what they want in their vending machine. So it does become a little bit biased, and they're going to want the foods that they prefer. So our answer for this question is 2143. Okay, number 33. So what we want to do with this one is we've got an image here and it's drawn in our Cartesian plane. And we want to figure out which of the following describes line segment AB, and we want to describe it with an equation. So the first thing I'm going to do is highlight AB. So anytime we see those letters, all they're saying is referring to a line that has those points. So here is point A and here's point B. So it's going to make a line called AB. Now the second thing is we want to know the equation that's going to represent it. So the first thing we need to be clear about is which axis it's crossing. So remember, our y-axis is this way, it's nice and vertical, and our x-axis is like this, okay? So I like to think about that as like y standing up nice and tall. So that means our line is crossing our nice and tall line of a y-axis. That means right off the bat, we know our equation to represent this line has to start off with y equals. So I'm going to cross off anything with x equals. And then now we just have to count it. So our line is at the bottom here of our graph. So that means it's going to be in the negative numbers. So here is 0, 0, negative 1 is here, negative 2 is here, and negative 3 is here. So this one is going to be y equals negative 3. Okay, number 34 here. So with this one, what I did was I actually added some of the things that we have to keep track of on for this question. So what's happening here is we've got our objects. Now, all of these objects are made out of those linked cubes. With those cubes, what you want to do is imagine putting them together in these orientations, and we need to figure out our surface area. So one of the things with this is we want to think about it as if we were to be wrapping every part that we can see with wrapping paper. So we're not going to really worry about the parts that are touching each other. It's all the parts that are kind of like on their own, okay? What we're also going to do in terms of strategy is we are going to count how many we see on the front, recognize that that's almost always going to be the same as the back. Then we're going to count the parts that we see on the right, the left, top, bottom, and then the other part that we need to think about are the parts that are kind of hidden that you would really only see if you were to flip the object kind of upside down, okay? So let's take it back and let me kind of walk you through this slowly. I know this can be confusing, and one thing I do want to mention is if you can get your hands on a set of cubes like this to actually build it, especially if you're having trouble kind of seeing everything, I definitely recommend that, and that'll just help strengthen that visual perception of what's happening. So let's look at it so far. So we're going to count the front first, and sorry, let me back up. The reason we're doing all of that is because the question's asking which of the following statements describes the relationship between these objects, and as you can see here, we are looking at surface area for all of them. So we have to figure out the surface area of all those shapes. So let's start with the side that's facing us. So I'm just going to go ahead and count them. Perfect. So we've got 8 on the side that's facing us, and that's going to be the front. We're going to do the same thing with the back because they're mirror images of each other. So that's going to be the same there. And then let's look at the top. So with our top, we've got 1, 2, 3, 4. Perfect. So our top is going to be 4. Now with the bottom, what's happening is we've got 3 here, But if we were to imagine flipping this whole thing kind of upside down, we would also see the bottom of that. So that means our bottom is actually made out of 4. Now for the right, we're going to see 1, 2, 3. And that means we're going to see the same thing for the left. Okay, so here's that tricky part. We have to account for those hidden parts. So our hidden parts are going to be here. That's 1, 2, 3, 4. So if we add all of those numbers up together, we are going to get a total of 34. Okay, let's do object 2. Okay, object 2 here. So same idea, right? We're going to count the same things for every part. So our front going to be 8, which means the back will also be 8. Now our top is going to be 3. The bottom, in this case, there's no kind of overhanging portions here. So this one is also going to be 3 for the bottom. The right is 1, 2, 3, which is going to be the same thing as the left there. I'll actually draw those in. So that's going to be 3 and 3. And then for the hidden portion, it's not too bad for this time. It's just one hidden portion kind of there and the other that's hidden there. So that's going to be 2. So we can add all of those numbers up together, and for object 2, we're looking at a surface area of 30. Object 3. So let's do the same thing as we've been doing before. And then just like last time, the front's going to be the same as the back. For the top, this one is a little confusing. So this is half, that's half. So those two halves make a whole. So that is going to be 1, and that's going to make this 2 and this 3. So the top is actually going to be 3 here. And for our bottom, it looks like it's going to be the same. So that would also be 3. For the right, let's count those. Okay, that's going to be 4, which means our left is going to be the same thing. We can double check. So we've got 1, 2, 3, 4. The left is also 4. And then for our hidden portions, let's go ahead and count those. We've got 1 hidden here, 1 there. That's 2, 3, and 4. So all together, this is going to add up to 34. Okay, now let's go ahead and let's look at the relationships between all these objects, okay? So object 2 has a greater surface area than object 1. Well, object 2 does not have a greater surface area than 1, so that will not work. The surface areas of 3 objects are the same. We know they're not the same. Only 2 of them are the same. Object 3 has a greater surface area than object 1 and object 2. Again, not true, right? In fact, like I said, those 2 are the same and this one is the smallest. So that does leave us with option D. Let's verify. So the surface area of object 1 is equal to the surface area of object 3. I'm liking that one. So that is definitely going to be our answer for question number 34. Okay, number 35 here. So I'm looking at this one and we have to evaluate this expression. So one of the things whenever we do see something like this, we do want to think BEDMAS. And as I've said before, right, this test was made before calculators, or this test was made before the mental math part of the PAT. So I would say this one would be a great one that you would find on probably part A. But let's go ahead and let's evaluate it. So with BEDMAS, the first thing we want to evaluate is our exponents. So the key thing with this one that I'm going to keep repeating is whenever you can, I'm just going to zoom in on that, whenever you can, rewrite your expression. Every time you rewrite it, you're going to make sure you don't actually make any mistakes, but you're also going to be really organized in everything. So I'm rewriting everything. And with BEDMAS, the first thing is brackets. There are no brackets, but there is an exponent here. So I'm rewriting everything, evaluating my exponent. Perfect. Now, the other thing that I'm looking at this is that 0.75. Why don't we turn that into a fraction? So 0.75, and I've said this before, is like 3/4. So we can just label that as 3/4. All right, now with BEDMAS, our next thing to do is to divide. So we want to divide these fractions. So with divide, we're going to do something called our KFC method. That stands for this over here. So let's divide our fractions. And again, I'm just going to rewrite everything. And I'm going to go ahead and flip this one. So that's going to be 1/4 times 2/1 minus 8 times 3/4. Okay, let's evaluate that further. So for multiplication, we're going to go top times top, bottom times bottom. That leaves me with 2/4, take away 8 times 3/4. We can evaluate the 2/4 into simpler terms. So if I think of a box and I've got 2/4 filled in, well, that's only going to leave me with 1/2. So this can be simplified to just 1/2. So that takes care of, let's go back to our rules here. We've done our exponents, our division. Next is multiplication. So with our multiplication, we're going to multiply these two portions together. We have a whole number times a fraction. So we can just turn this into a fraction and then do the same thing as we did above, top times top, bottom times bottom. Let's rewrite everything. So 6, take away 1/2. And I'm just going to bring that subtraction sign down with it and multiply the fractions as if they're positives. So we've got 8 times 3, which is 24, over 1 times 4, which is 4. Now again, we can simplify that, right? So 24 into 4 groups is going to give me a whole number of 6. So this is going to be rewritten as 6, take away 1/2, take away 6. Okay, let's keep looking at this. So we've taken care of our multiplication. We have no addition, so just our subtraction. So if we go left to right, what we can do is we can say, well, so if I look at this, I can look at this as I've got my 1/2, but I'm noticing something here. I have 6, take away 6. Or if you want to do it positives and negatives, even though it's the same thing, we can say positive 6 and negative 6. So that's actually just going to cancel out these terms, leaving us with our answer of negative 1/2. So the answer to this one is actually just going to be A, negative 1/2. Okay, let's work on this question here. So this question is an interesting one. So they gave us a key, and now remember, whenever they give us a key with this, we have to pay attention because they do like to switch what is positive and what's negative. But in this case, our shaded are positive and our unshaded is negative. What we want to know is which of the following expressions could represent polynomial number 4 if the sum of all 4 expressions is 6, okay? Or 6x, excuse me. So what that means is we added all of this together and we got 6x. But our job is to figure out the missing portion here. So this is kind of like a subtraction question a little bit if you think about it that way. But to make our lives easier, why don't we first combine all of this together? So when I combine them, what I do know is every time I have a positive and a negative, that's going to make a 0 pair, or it's just going to go down to 0. So I'm going to do each individual polynomial first, and then from there we can figure out our missing piece. So right away, I know this is going to cancel with this, and I'm just going to actually just go in order of the polynomial to keep it simple to begin with. So that's going to cancel out, and this is going to cancel out. So that leaves me with 4x minus 1. Okay, let's do the second one. So again, anytime I see a positive and negative, I'm going to just cancel them out. So that's going to leave me with 2x minus 2x squared minus 1. Perfect. And I'm actually going to move, just because it's convention to do it this way, we're going to put the x squared kind of at the start and our x right there. And our 2x was positive, so we can put a plus sign there. Okay, and then finally our last one. Those two are going to cancel, these two are going to cancel, and now we can just collect our like terms. So this will leave me with negative x squared plus negative, oh, I guess it would just be a negative, so negative x, and then our positive 4 left over. So we know it equals to x. So let's combine everything here together. So I'm going to look at all my x squares and combine those. That's going to leave me with negative 3x squared. With my x's, I've got 4 positive and 2 positive and 1 negative, so that's going to leave me with 5x. There we go. And finally, my last one is negative 1 and negative 2 plus 4. So for this one, I've got 2 negative things and I'm adding 4 positive things. So 2 of those negatives will cancel out with 2 of those positives, leaving me with positive 2. Okay, so now that we have our total of the 3 polynomials, we have to go back to what the question's actually asking us. So it says, which of the following expressions could represent polynomial number 4 if the sum of all 4 expressions is 6x? So what that means is I've added up 3 expressions, but I'm still missing one. So my 3 expressions look something like this, which I'm just copying from the corner of my screen there. And then we're saying we're still gonna add that to polynomial number 4. So I'm gonna put a little box around that, and that total is equal to 6x. So what I need to do is I'm saying, this is no different than saying like 3 plus 3 equals 6, but we don't actually know this 3 here, so we have to work backwards. So in essence, I could have written it like this: 3 plus blank equals 6. So what goes in the blank? It's just in this case, instead of it being a simple blank that we can fill in with a number, it's actually an expression. So what I want to do is I want to do the opposite of everything. I'm going to move all of these terms over to this side, and that's going to leave me with polynomial number 4 alone, which is the answer that I'm looking for. So in order to move it to the other side, I have to add the opposite to each side. So I'm going to add positive 3x squared to this side and add positive 3x squared to this side. And then I'm going to do the same thing with the negative 5x. And then I'll do the same thing with the last one here, minus 2 and minus 2. So what we can notice here is there is a set of like terms just right here that I can combine. So that's going to leave me with that's going to leave me with 3x squared, which is just coming from here. Our like terms can be put together here, which leaves me with positive x, and our minus 2 we can just bring over. Altogether, that's going to leave me with my answer, which is going to be option B. Okay, number 37 here. So with this one, again, we need to pay attention to that key, and we've got our expression, and they want to know with our expression, what's the number of terms we have and the degree. So I'm going to write this out just for those of us that don't like the tiles. So if I were to write this out, this would leave me with negative 2x squared plus 4x plus 5. So with that, we can start to look at the number of terms. Well, the number of terms in tiles just really means the different shapes. With our numbers, it really means the different exponents or existence of no exponents, which will represent a term. So in this case, we are looking at 3 terms. So that means we can cross off option A and option B. And then our degree, well, our degree is going to be the highest exponent that we have on the polynomial. In this case, our highest exponent is 2. So that leaves us with option C as our answer. Okay, numerical response number 9. So we have a large sail that's shown below, and we know it has an enlargement. So we don't know the dimensions of the original one, but we do know we zoomed in on it or we made it bigger, almost the same way as saying like you looked at a photo and you zoomed in on a photo. We kind of did the same thing here. So what we did though is we did it with a factor of 2.50. That means whatever the dimensions were here, I multiplied the whole thing by 2.50 to get my new enlarged sail. But let's take a closer look at the question. The question is asking us, what is the height of the small sail knowing this factor? So what it's actually asking us to do is it's asking us to go backwards. It wants us to go this way and figure out the height. So let's think about this. If we go from small to big, we had to multiply. If we have to go the opposite direction, then we have to do the opposite operation. So that means in order to find out the height of this, we are going to need to take our enlarged height, our height of 280 centimeters, and we're going to have to divide it by 2.50. So when I do that, I'm going to get a scale factor. Actually, I was going to show it to you all. So 280, and we're going to divide that by our factor, and that leaves me with 112. So the height of this is 112 centimeters. Okay, number 38 here. So with this, they've given us a triangle JKL, and we can see their points here. And with those points, what we've done is, or what we're going to do, I should say, is we are going to create a transition of 3 units to the left, 4 units down, and then we want to rotate it clockwise, so that's towards the right on point L, okay? The other thing that we'll have to do is once the entire triangle is drawn and we've created those changes, we need to figure out its new kind of, and we need to figure out its new points. So let's start by doing this first. The first thing I'm going to do is trace the triangle, and then we're going to go ahead and move it based on those instructions that they gave us. I'm actually just going to color it in for my sakes, just to kind of keep it nice and clear. Okay, so what I'm going to do is I'm going to go ahead and move it. So we're going to move it 3 to the left. So I'm just going to keep my eye focused on point K, and let's move that 3 to the left. So 1, 2, 3, and then we have to move it 4 units down. So 1, 2, 3, 4. Okay, now we need to rotate it on point L. Now, if you have tracing paper at home, and you can go ahead and rotate it, what you're going to do is you are going to place your tracing paper on top of the image, hold down point L with your pencil and rotate the paper. On the iPad here, it's going to be a little bit tricky, so I'm just going to keep my eye glued to where point L is and make sure that is always joining up on the graph there. You can see I move it a little bit just because of the way it wants to orient everything here. Perfect. Okay, so now as I said before, we need to figure out the actual points on those. So I'm going to go ahead and write in all the points on the graph here. Okay, so now that I've got my points, let's go and write those letters in. So I know that this is L prime. So prime, or the apostrophe on it, just means that that's our new version of our original triangle. And now we can go ahead and figure out our points. So point L is going to be -3 and -2. Remember, we always go from X to Y. Point K is going to be 1 and -3. And J is going to be 0.1 and -5. So now we just have to find an option that matches to that. So let's see here. I'm going to start with J first. Okay, that one looks good. Actually, I think that's going to be it. It looks like it's just going to be that. Let's verify our other ones. Point K is 1 and -3. Looks good. And L is -2 and 3. It would help if I wrote it correct. So that would be -2 and 3. So that leaves us with option A. Okay, number 39. So with this, we know we have similar triangles. So similar triangles basically mean we have a triangle where all the angles are the same. The only difference is, again, we zoomed in on one or we shrunk one depending on how you want to look at it. So with this, we've got our big triangle and we know it's similar to this one. Our job is to figure out our length of BC. So here's our length here. So because they're similar triangles, we can actually set them up so they're going to be equal to one another. So I'm going to say 2y plus 5, which is my length of BC, is equal to the same side, but on the smaller triangle. So in that case, it's going to equal y. And we're going to put that as like almost ratios, if you will. That's going to be underneath our 18 and our 6 here. So 18 and 6. So all I did was I said, well, this represents one triangle, and that triangle is represented by the same thing here, but they're equal to each other. So now that we know they're equal to one another, we can actually just solve for y here. So we can do a little bit of cross multiplication here. And that's going to leave me with the following. And then we can go ahead and distribute everything there. And now we can just use our algebra and solve for y. Divide both sides by 6 to get y alone. So I am getting y equals 5 here, but that's not our answer, right? We can see there's no option there. So let's go back to what we had to do. We need to figure out the length of side BC. Well, BC is equal to 2y plus 5. Well, we know that 2 times y, which we now figured out is 5, plus 5. So now we can calculate that together, and that gives us 10. So the length of BC in this case, that gives us 50. So the length of BC in this case is going to be 50. The chart here, the chart shown below, shows the life expectancy at birth of males and females in a particular country. So we can see our chart here, and right off the bat I am noticing some patterns, and this is actually quite common. Females tend to live a little bit longer than males, and we can see as each year goes on, the expectancy goes up. So what we need to do is we need to decide which of the following assumptions supports the prediction that a female born in the year 2020 in this country will live to the age of 80.7 years. So let's go through and let's kind of cross them off. Females in this country live longer than males. Well, that is true, but I don't know if that really supports a prediction. So I'm just going to put that as a star. The life expectancy for females will continue to slowly increase. Now I do like that because we can see they are slowly increasing. So I like that one as well. C says changes in the environment will reduce life expectancies by 2020. Well, we have nothing that really talks about anything in the environment, so that one would not work. And for D, the gap between the life expectancies of males and females will be smaller in 2020. Again, we're not really seeing that happening. If that were true, we would start to see these ages more closely aligned with one another. So let's go back and let's decide between A and B. So the question asks us, which of the following assumptions supports the prediction that a female born in the year 2020 in this country will live to the age of 80.7? So the only one that's really talking about that is really talking about a continuation or a prediction is going to be option B. Because again, it says the life expectancy for females will continue to slowly increase, and we can definitely see that right there. So our answer for this one is going to be option B. Okay, everyone, you are officially on the last question. I am so excited for you. Good work in keeping up with all of this. So let's head into that last question. All right, we are looking at this question here. So it asks us, which of the two squares shown above best represents the best benchmark for estimating the value of the square root of 43? So the square root of 43 is really in between the square root of 49 and the square root of 36. So if I were to evaluate that, that would give me 7 and 6. So now what we need is a square that has the side length of both 7 and 6. So the first thing I can do is I'm looking at this one, square 1, and this is going to be a great option. It definitely has a side length of 6, so that would work. And now I need a square that's a little bit bigger than that. That would be this square right here. 1, 2, 3, 4, 5, 6, 7. So our answer for this would be square 1 and square 4. Congratulations on working through all of that. I know it wasn't easy. In the description, I've got 2 things for you. The first one is a Kahoot, so you can practice your learning. And the second is just a reminder, I hold one-on-one sessions, so if you need help, again, you know where to click, where to find that information. And finally, make sure you subscribe and keep an eye out for all the Science Practice PAT videos that are going to be coming your way. Until then, I will see you all in the next one.